Good morning students. Today we start thermal effect of electric current. We use many different electrical appliances. Electrical appliances means what, like bulb, fan or whatever we use with the use of electricity, whatever is useful to us. Na? So everything is called as a electrical appliances in our daily life and are aware that they generate heat when used for a prolonged time. So prolonged means long time. When we use the electrical things, they produce the heat energy. Yes, for example, you put on the TV. After some time, when you touch the TV, it will be hot. And when we recharge the mobile, after some time, when we touch the mobile, it will be hot. Yes, and when we are continuously using the mobile, it becomes hot. Okay, so when we continuously using the electrical appliances, they produce some thermal energy. Thermal means heat, some heat energy. For example, bulbs and motors becomes hot after some time. When current flows in any conductor, conductors means metals which conduct the electricity, some electrical energy is lost. So that heat energy which when we feel that heat energy, that is the lost energy. Okay, that means when the electrical current is flowing in the wire, some electrical energy is used by the bulb or electrical things and some energy is wasted. Okay, that means that is the energy when we touch we feel as a hot. So as per the law of energy conservation, conservation means what? Saving energy. Energy cannot be created or destroyed. So in the reactants, in the equations we saw, so the energy is not created during the equations. How much reactants we use, that much product only we get. For example, C plus O2 gives rise to CO2. Here carbon how many? 1. Oxygen how many are there? 2 are there. So here also you see we get the product. Carbon 1, oxygen also 2. Same thing. So how much? So during the equation, energy is not created. That means extra energy is not added or energy is not wasted. How much is there? That much product only we get. So like that only. So but can only be converted from one form to the another. For example, to glow the bulb, electrical energy should be converted means what? Changes into the heat energy, then only light is able to glow. And in the motor, electrical energy changes into the mechanical energy, that time only motor is able to work. Okay, so therefore the electrical energy lost is transformed into heat energy. So we are feeling hot when we touch the bulb or the any mobile charge, when it is prolonged time using the electricity. So that means the electrical energy changes into the heat energy. So this effect is known as a thermal effect of electric current. Okay, so just underline this point. The electrical energy lost is transformed into heat energy. This effect is known as what? Thermal effect of electric current. Thermal, what is the meaning of thermal? Heat. So that means the heat energy will be changes into the electrical energy, changes into the heat energy. This is called as a thermal effect of electric current. So the heat generated in a circuit is due to this thermal effect of current. Okay, so this is one circuit. Now here you see voltmeter. What is the use of voltmeter? It helps to measure the potential difference. What is the use of the ammeter? It helps to measure the flow of current in the circuit. Okay, always ammeter is connected in the circuit in a series level. Series means in a straight way like this. But voltmeter always connected in the circuit in a parallel way. Parallel means like this. Okay, so that is this one. So this is called as a resistor and this is the wire and this symbol is the switch key and this one is the battery and the next this is the ammeter. So this is the circuit. Okay. So the heat generated in a circuit, generated means produced, the heat produced in a circuit is the, what is the thermal effect of current. Okay. So now this is very important. Okay. Thermal rule of Joule. So when you keep the Joule, so what is this one? Joule means the SI unit of the heat energy. Okay, we have the SI units. For example, for the solids, vegetables and everything, when we measure, what is the SI unit we use? Like kilograms, grams or milligrams. So like that only for the heat energy, what is the SI unit? SI unit is the Joule. Okay, so thermal rule of Joule. Given that, now you observe I. I means what? Current. Okay, flows for T means time. Flows for T seconds across a resistance R. So resistance means what? Which controls the flow of current. And a potential difference V. V means potential difference is set up between the two terminals of the resistance. Okay, to set up two terminals of the resistance, means terminal means what? Ending point. So this is the resistance, this ending point, voltmeter is added. So voltmeter used for the to measure the potential difference. Okay, so this is the one. So the charge flowing in a wire in T seconds, charge is represented by which letter? Q. Okay, right side by Q means charge, and current means what? I. Time is T. V means potential difference. Then all these words you should know. Okay. So current flows for a T seconds. T seconds of some seconds of time across a resistor, and a potential difference is V set up between the two terminals of the resistance. So charge flowing in the wire in the T seconds. When the charge flows in a wire, positive and negative charges, when they flow in the wire, so automatically it is the electricity. The flow of charges is the electric current. Okay, so for unit of time, for some time, so into time, current into time. Okay, so the next one, so or Q means what? Charges. So Q means charges, I means current, and T means time. So that is why Q is equal to I into T. From the definition of potential difference, the work done to move a charge Q in time T across the two terminals, work means work done, काम करना. Okay, work done. So charge is Q. So when the charge goes across the two terminals, charge means Q. So charge is going across the two terminals. Okay, across the two terminals in a T time. Okay, so W is the work done. Okay, is equal to Q is the charge. Okay, and across the two terminals means what? This one, across the two terminals, this is the potential difference. Okay, across the two terminals. So that is why here W is equal to QV, and Q is equal to, so V. Okay, so in the place of Q, we write I into T. Understand? Q means what? The flow of charge. When the flow of charge is what? Current in a some time. That is why Q is equal to I into T. I means time. So work done. So from the definition of the potential difference definition means what? The work done between the two terminals when the charges are started to flow in a current wire. So that is why W is the work done, Q is the charges, V is the potential difference. And Q is equal to, so what is the Q actually? Q is the flow of current in a time. So that is why I into T. So therefore W is equal to, okay, so W is equal to V, potential difference V, in the Q place we write I into T. So W is equal to V into IT. Okay, so the work done to move charge Q from one end to the other end across the resistance R manifests itself as the great heat generated in the resistance. Okay, so here you see the flow of charge from this terminal to this terminal across the resistance. Okay, one terminal to the other terminal across the resistance Q. That time heat is generated. Okay, so this heat we take it as a capital H. Okay, so instead of W, because of the work done only heat is generated. Because of the charge flow in the resistance, heat is generated. So in the place of W we write the H. Okay, so here WH. Okay, so H is equal to VIT. Okay, W is equal to H is equal to VIT.